In today's video, we will discuss the basics of water and how we use it to heat or cool a building. We will cover a few different topics, including the importance of where we get water, the process of heat transfer in different systems, heat exchangers, and how water treatment can help extend the life and performance of heating and cooling systems. First off, let's take a look at some different options of where our incoming water originates and why that is important. There are two major types of water, groundwater and surface water. Groundwater is water that we get from below the surface, such as well water or from an aquifer. It generally contains much higher levels of suspended and dissolved solids due to the different rocks and minerals it percolates through as it collects in wells or underground aquifers. Surface water typically contains much higher levels of dissolved gases, pollutants, and dissolved organic matter due to making contact with dirt, leaves, and other organic materials as the fallen rain collects in streams or lakes. As a general rule of thumb, groundwater is more scale forming, and that makes it difficult and expensive to treat due to the high levels of dissolved and suspended solids. Now let's take a look at a very basic idea of how we use water to heat or cool a building. We do this through a process called heat transfer. Water is an excellent material to use for heat transfer due to it being safe, inexpensive, doesn't require a lot of additional energy to transfer the heat, and is readily available. Temperature is a measure of the relative thermal dynamics of a substance. A hot substance has more heat energy and can generate more, whereas a cold substance has less heat energy. Both heating and cooling involve moving heat from one place to another, or heat transfer. Water is an excellent heat transfer medium because it has the ability to reject or absorb large quantities of heat through evaporation and/or freezing. When cooling a building, there are system components used to remove heat from the air being drawn in, and eventually that heat and energy are released by the cooling tower into the atmosphere. We are using a combination of the fans either blowing air through or drawing air across the fill to remove the heat from the water and dropping the temperature of that water roughly 7 to 10 degrees based on the design of the cooling tower. The water is then moved to some form of a heat exchanger where it then removes heat from another system. In many cases, there will be a secondary loop that will flow through the building piping and pass through the coils in an air handling unit where the initial heat exchange takes place and the cooler air is distributed throughout the building. The water in the pipes then return to the heat exchanger and the process begins again. There are other system components that can help with the heat transfer such as condensers, heat exchangers, and chillers, but we will discuss these in greater detail in other videos. Now let's discuss heating. In order to generate enough heat to heat an entire building, boilers are used for efficiency. Boilers use hot water or steam to heat a building in a similar fashion as cooling, but instead of removing heat from the water, we are heating up the water with fire and combustion. The hot water or steam is pushed through the building within the pipes, and the water is sent to the air handling unit coils, and the steam is sent to either heat exchangers or radiators. You have probably seen a radiator in an older building. Steam moves within the cast iron steel unit, and the heat radiates through the room. The more common mode of heating a building would be where the hot water is sent through pipes to the air handling unit, where air is pushed over the coils, and the heat is transferred to the air and distributed throughout the building. Steam can also be used to heat the water through a heat exchanger, and then the water on the other side flows through the air handling unit coils. So where does water treatment fit in with all of this? Earlier we were talking about the dissolved gases, solids, and organic matter in the ground and surface water. While those dissolved gases, solids, and organic matter can cause issues like scale, corrosion, sludge, buildup, microbiological growth, and other issues in a heating or cooling system. Our products are designed to inhibit or prevent the impurities from doing any harm to the equipment and maintain peak efficiency of the systems. Just a small amount of scale on a tube bundle, a heat exchanger, or within the pipes can lower the efficiency of the system significantly. This can greatly increase the energy cost the customer sees on their energy and utility bills and cause the system to work harder than necessarily, potentially shortening the life of the heating or cooling system equipment. Corrosion in a heating or cooling system can cause a number of issues, including wear, tear, and leaky pipes. Leaky pipes lead to higher use of water and chemical, and a loss of metal within the system leads to equipment failure and costly repairs. Corrosion byproducts such as iron, dirt, sludge, and debris also contribute to deposit formation. They can plug up pipes and pumps and cause leaky pump seals and valves to fail. Over 80% of water treatment business is won or lost on the efficacy of the biocide program. Proper biocide programs help prevent system failure and damages caused by microbiological growth. If allowed to grow unchecked, microorganisms can cause severe corrosion and slime deposits in the water and shut down a system overnight. Cooling towers are particularly susceptible to microbiological growth since they provide ideal conditions for growth of problem-causing microorganisms. Furthermore, if the conditions are right, disease-causing bacteria such as Legionella can thrive in a cooling tower. Scale, corrosion, sludge, and microbiological growth can ultimately lead to reduced heat transfer, flow restrictions, increased operating costs, reduced equipment life, and system failure. This is why it is important to follow the guidelines that ChemsearchFE provides for all water treaters, as well as scheduling annual system cleanings. Be proactive and use the resources available to ensure successful water treatment for your accounts. There are numerous resources available to you on the FE app, the ChemsearchFE YouTube page, H2O Info Center, and H2O Tech Support. Be sure to watch the other H2O Solutions videos available on the FE YouTube page to further your knowledge of water treatment. Thank you for watching this H2O Solutions tutorial video.